okay, during my time, okay, during my class, okay, during my class, okay. So even though we're having a session, my expectation actually high. Okay, when I share the videos, when I and then we all together listen to it, I want to really alert, okay, and try to grab something, okay, from the videos, okay, that you watch, okay, because after the video immediately, okay, we're going to discuss. I'm going to pose a few questions, okay, to see whether you manage to grab, the ideas, from videos, and you can ask me something as well, from the videos if you have any concern, okay, for instance. Is it clear, class? Okay.
Yes.
All right. Okay. Good. So I'm going to share my screen, okay, but please, I mean, my apology, if you see that my screen actually is not that tidy. Okay, a lot of things, okay, that I put on my screen. Okay, sometimes I do that in purpose because it's very easy for me to find out later on. Okay, so can you see the screen? I'm sharing, the document, for the course teaching plan, okay, a CTP, all right? Can you see it, Ananda?
Yes.
All right, okay, good. I think you have seen, this file or this document more or less. Okay, it's been shown maybe by Prof. Dr. Chi-Wan, and because normally we share this, with student at the early of the semester. Okay, right. But not actually we are on the second half already. So the CLO1, CLO2, DL3 actually the expectation, and basically, the lectures taken that we prepare for you, the exam question, and some of the activity, including the tutorials, including, the assignment, actually is going to answer. Okay, these three CLO, CL1, CLO1, CL2, and 3. Okay. So among others, okay, differentiate the essential concepts, principles, and theories of various spectroscopic techniques. Okay, because in this case, I think here alone, in this course alone, actually it's part from fluorescent, UV visible spectroscopy, and also NMR that you're going to learn with me. Okay, but for the first few weeks, okay, you already learned, okay, about the FTIR, I suppose, and then I think mass spec, okay, with Prof. Chi-Wan. Right? So those methods, okay, those spectroscopic techniques, as considered very vital, Okay, I repeat that, okay, because of as a chemist, okay, you're expected to know not only to know the theory, okay, but we expect you should be able, okay, to run the instruments. Okay, so like, okay, that's why, during your lab session, okay, um even though, okay, you are working in a group, okay, but whatever opportunity that you have in front of you, okay, just grab it, okay, just grab it, so that at least, okay, you have, some hands-on experience. And that's going to be advantage as well, if you understand the concept, okay, maybe during the interview, for instance, okay, you can really master, okay, in terms of, the discussion, okay, that you have, maybe with the interviewer. All right. And the second CO2, back to display the ability to conduct experiments and on analysis of compounds and interpret the spectrum obtained. That's happened, in your experiment, isn't it? Okay. You are given, the lab manual. Okay, you need to do that, in a group. And this year, actually, we try to limit, okay, the number of members in a group. Okay, just merely maybe two of you in a group, but then, as an experiment, okay, maybe it's a four or maybe slightly more, okay, of student, I mean, per instrument. Okay, that's the best that we can do. Or as I said, try to grab every opportunity that you have while you are in the lab, while you are the instructor. Okay, maybe your instructor is me, or maybe Dr. Saza. And while you are with the assistant, okay, try to grab as much as possible from them. Okay, this is part of the learning process, because surely not many that we can cover, in the class. All right. So CLO3 to elucidate the spectra of four-dimensional structure analysis of compound. We expect you, okay, to be able to do this. suppose in the exam, okay, you know, the exam paper, you know, that I just submitted. Actually, I put, you know, some unknown, okay, some spectral, okay, some NMR spectrum, okay, for unknown, and we expect you, you know, to be able to elucidate, okay, what sort of, you know, carbon, okay, available in that compound, okay, how many what you call it, how many hydrogen atoms available, how many types of them, you know, and then what's other information, okay, like, you know, the structure. Suppose that you are given the compound, suppose you are given the compound, okay, the compound, you should be able to guess, okay, which compound actually belong to the spectrum that been given to you. Macam tu lah, yeah. Okay, right. Basically, as you know, I mean, you know, the carry marks, okay, it's like this. A lab, okay, 50%, okay, so don't take for granted for your lab, 50% is quite a lot, okay. And then group assignment, okay, it's about 15%, okay, so half is go to Dr. Shiwan, another half, okay, will come to me, okay. So meaning you will get some assignment, okay, from Chip One, and another half, maybe 7.5%, okay, from me myself. And apart from that, we have final exam here. Final exam actually about 30%. Final exam 30%. And then midterm, okay, midterm. I think maybe what 20%, okay, and quiz, okay, quiz. I mean the total up, like it's about 70%. You know, and I need maybe I think by now maybe you know the detail. This the distribution of this weightage, okay, among these three components. And for the quiz, again, normally I will enter the quiz because in my case I'm not going to give you, you know, it's a proper quiz. It's always what I'm calling as pop quiz. Pop quiz meaning the quiz will be pop out, you know, at any time you can do the lecture, okay, or before the lecture, you know. But normally what I did, okay, I'll put, you know, the quizzes, you know, the question, I mean the quizzes questions, you know, I'll put it, you know, in the attendance. Once you go to attendance, okay, you will find some questions, okay, that I ask, okay. So I normally based on that alone, and almost every single attendance, okay, will come, you know, with the quiz, okay. But today I don't put a quiz there because this today actually your first class, and I don't have last week actually I don't have much time, okay. I mean to share, you know, the what you call it, the material early to you, okay. Normally I shared, you know, early, and then you can have a look, you know, glance through, you know, the material, and based on that, okay, you can basically you get some, you grab, you know, some gist, okay, of the material, and you are able to answer, you know, the quizzes, okay, that's been provided. But the quiz actually, you know, it's not really it's not really very challenging. You know, I just want to test first. You know, I want to test whether you already gone through, you know, the materials or otherwise. And secondly, you know, I want to know your understanding. Okay, but there's actually just really lower level. Okay, so just to test, you know, basically on the knowledge. You know, so very simple question. Okay, basically. But for today, actually, no question apart from I'm just asking, you know, I'm just asking your opinion, okay, regarding your feeling, you know, your opinions, okay, for the past 7 weeks or 8 weeks, if you like, okay, that you have gone through, okay, whether you have any feeling, any suggestion, and so on. Okay, another. These are basically, you know, the weekly teaching plan, okay, just like a teacher you going this month. Okay, so basically you have finished, okay? So until week 8 ni, okay, week 8, okay, on the 16th, and today 23rd. So I'm starting, okay, with the one. So kalau ikut schedule, okay, I'm supposed to start with NMR, and then we're having, okay, because I mean the what you call it, I mean the material actually is quite or the subject itself actually is quite wide, okay. So we take 2 weeks, okay, for each. So NMR, okay, part 1 and part 2, UV visible, part 1 and part 2, fluorescent, part 1 and part 2, okay. So today I'm going to start, you know, with UV visible first, because I think this is actually the simplest, and because you already done, you know, the experiments. So after UV visible, I will continue with fluorescent, and lastly, you know, I will go into the NMR. Why? Because UV visible and fluorescent, the concept is the same. So while your understanding about the UV visible spectroscopy is still fresh, so I will jump again into fluorescence. Okay, because the concept is the same. The only things, the alignment. Okay, I mean the way we measure, we measure different angle, but we're going to discuss that. Okay, later on. Okay, when we come into it. Okay, so basically 3 areas, okay, of spectroscopic, okay, that I need to cover, okay, starting from today until the end, of the semester, okay, which is on the UV visible spectroscopy, on the fluorescent spectroscopy, and then the MS spectroscopy. So another basically these 3 spectroscopy is considered, very basic, okay, it's considered very basic, and most of them is available in any what you call it, a chemistry lab. You go to any private lab, okay? You go to any private lab, okay, normally they will have, these 3 instrument, okay, because this is actually considered quite cheap, okay. For instance, okay, UV visible, okay, for the decent one, okay, the one that you can use, for both qualitative and quantitative, okay, normally will cost around about 200K, okay, so taklah mahal sangat, 200K. So similarly with fluorescence, okay, so 200K, 250K, okay, you are able to, to purchase, okay, compared to macam GCMS, okay, that's going to cost, and some of them actually can reach up to about 1 million, okay, ringgit. Okay, so even though because it's simple, so we expect, that you should be able to know this knowledge, in yourself. Okay, make sure before you come out, from OC, before you graduated, okay, you should master, all these techniques again that you have learned, okay, in this subject. All right. Ini teaching activities ni. Yeah, normally, okay, we having lectures, we having lectures and also tutorial. Tutorial, actually, I was informed by Prof. Cik Wan. Actually, we don't have a specific slot for tutorial, but since, your lab work actually is going to take only 4 weeks, so I mean that slot is going to be available. At the same time, we also not hoping, okay, to have tutorial, every week. So we are okay, I mean, to take over, the slot, okay, after you done, okay, with your lab. Sekarang ni lab dah habis ke belum, anak anda?
Belum.
Dah sampai bila? Berapa lama lagi? Altogether, how many lab that we have?
4.
4 je kan? Tak,
Yes.
kenapa ada ekor ni suara ayah dia? Right. Okay. So any question, another? Any question regarding, the subject, okay, regarding the topic that, the ayah dia need to cover? Any question, okay, regarding the assessment, okay, that you want to know? Yeah. Any question?
Not yet, Ayanda.
Okay, not yet. Okay, so I start this for a while. So I think now, okay, so I start, with the concept of spectroscopy first. I suppose this also has been done, okay, by Cik Wan. Okay, but just for the matter of untuk revision. Okay, before that, okay, I think any problem, okay, that you anything, okay, that you want to discuss with me regarding the subject and so on, okay, you can either message me. I think we are in the WhatsApp group. Okay, so my phone number. Okay, you can WhatsApp me anytime. You can also, if you like, okay, you can also come to my office. My office actually, just opposite the pantry. Basically, I'm the, under the pejabat arm of FKAB. Okay, FKAB actually first floor, so I'm just underneath. Okay, exactly underneath. All right. So in front of a fast lab. Okay, maybe that's easier for you. Fast lab, fast lab. So I'm opposite the fast lab. Right. Okay, so maybe I share the notes dulu, before I share the videos. All right. Can you see my slide here, Ananda?
Yes.
Okay, right. Okay. So the subject that we're going to discuss today, based on the UV visible spectroscopy. And little bit about myself. Okay, so my name is Ahmad. Okay, just address me as Ayanda. Okay, that's simplest and less formal. So fully by having that, okay, you will be comfortable enough, okay, to communicate with me. And just for information, I got my first degree. Okay, so I'm proud, okay, to share that my first degree, my BSc actually from University Kebangsaan Malaysia. So University Kebangsaan Malaysia, has been established in 1970. 1970. At that time, Ayanda was in standard 2, umur 8 tahun. Okay, 8 tahun. You, of course, you tak available lagi kan. Mungkin some of your parents also still not born yet. So 1970, I was in standard 2, Darjah 2. UKM was established, and my teacher in my class always talking about UKM. Like, always talking about UKM because UKM, I mean the philosophy, okay, how they established this university is different. Okay, because that's why I'm calling UKM as a university rakyat, because actually the aspiration, from the rakyat, okay, who want to establish, this university, and this university is going to use, bahasa Melayu, as the medium of instruction. Okay, mana dia ngajar bahasa Melayu. Okay. So my teachers, one of specific one, Cikgu Muhammad. Okay. So always, almost every day, before he start, okay, teaching in the class, we'll always talk about UK, and he hoping, that one day one of my student in the class is going to further your study there. And suddenly, I guess suddenly, when I finish, my secondary school, while thinking of choosing which university I want to go. At that time, actually, I have ambition, okay, to be a medical doctor. Okay, so somebody told me if you want to do your medical and then go to UKM, because UKM actually is going to have their medical faculty, and you need to do matriculation, okay, 1 year in UKM. So at that time, suddenly I remember, my teacher, Cikgu Muhammad tadi tu, and I said, well, this could be my chance, okay, to fulfill, his ambition or dia punya hope tu harapan dia. And that's where, I am, that's why I enter UKM partly. And I'm really proud, okay, to be, to be an alumni of UKM. But after that, for master and PhD, masters, I was sponsored by by GPA, more or less, GPA. They sponsored me to do masters in Manchester, okay, University of Manchester. And then after masters, I came back for 3 years working in UKM. So I served UKM as a lecturer. That time I'm only having my masters. But now actually you are not allowed to do that to be to be a lecturer. You need to have a PhD minimum. Okay. And after 3 years, I received a scholarship, okay, from British government, okay, under this Commonwealth Universities Associations, okay. So I dapat scholarship tu, and then ayah ada dapat tu dan tempat tu dia cari, okay. Maknanya British government cari tempat tu, and based on my what you call it, my research proposal, okay, I mean the place that I want to do my research, so they find the best university, okay, for that areas of research. And finally, I get back, my former university dekat Manchester. Okay, so that's where I came back to Manchester and did my PhD. It's very, 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 very long journey, but very exciting journey. For those of you, I suppose, you are now in your second year. You're going to enter your third year very soon. Third year is almost, another half semester, okay, before you embark, for your lifetime industry. And that's where, okay, you're going to be alumni very soon. And then suddenly, well, you finish, okay. So maybe some of you might think of doing PhD, might think of doing master and so on, okay. So you can start thinking, okay, at the moment. So PhD is more than just nearly seeking a knowledge, okay. It's more than that, actually. And if you're interested, okay, you can come and talk to me, okay? We can have coffee together. In fact, if you're interested, okay, to be a lecturer, if you are, for instance, if you have a thinking, okay, to be a lecturer, okay? A lecturer is not, it is more than just delivering a lecture, like I'm doing now. Okay, it's more than that. It's more than that, and definitely it's very interesting. Okay, So if you're interested, you can come and see me as well. Okay, we can have chat on that. Because initially, I don't really like to be a lecturer, because, seeing my lecturer at that time in UKM, I don't have any motivation at all. Okay, so that's why sometimes, you need to be really patient, you need to have a passion in your career, no matter whether your career actually you are a chemist, maybe in a big company, maybe you are a lecturer, or maybe you are researchers, okay, maybe you are just merely administrator, okay, for instance, okay, you need to have passions, because from your passion, people will see you, okay, will see you from outside, and they will feel, attracted to you in the sense, okay, that the way how you present yourself, okay, itu penting. So macam ayah anda, okay, when I was in UKM, looking at my lecturer, I don't really, I don't really motivated, okay, to be just another, just like them, okay. But I mean the fact at that time, because of recession, so basically my, what you call it, recession at that time. Okay, so I have no choice, okay, but to embark, in lecturer. But then I found out, wow, okay, so lecture is not bad at all. Okay, so if you're interested, okay, you can come, okay, to me, and we can have a coffee together. In fact, among more than 25 students, okay, who did PhD under me, most of them are now actually, having a lecture as a profession, okay, throughout the countries, in Malaysia. Okay, I'm not really forcing them, but I'm sharing with them, the interesting part, okay, the hidden part, okay, to be what's the profession of a lecturer all about. Okay, to selingan lah. Okay, what is spectroscopy, Ananda? Okay, maybe I need to ask you, okay, because you already 8 weeks, in this subject. Okay, what is spectroscopy? May I volunteers, from you? Any volunteers, okay, who are going to answer you my questions? What is spectroscopy, Ananda? Okay, ni you balik kampung raya kan? Balik kampung raya. Jadi nenek tanya, belajar apa dekat sekolah tu, dekat USIM tu? Belajar spektroskopi tu, contoh atuk tanya ke, atau nenek, belajar spektroskopi. So dia pun tanya, spektroskopi tu apa, cuk? Saya jawab ni. Okay, maybe Farah binti Baharudin. Farah, are you there? Farah, are you there? Ini satu lagi, kalau yang dia panggil tu kena nyaut. Kalau 3 kali, okay, ayah dia panggil tak ada bunyi, ayah tu consider tak hadir. Okay, even though you already take, your attendance, okay, ayah dia akan cancel kehadiran. Okay? So nanti bila dikira 80%, I think attendance, you aware kan? Attendance, it should be 80% and above. Okay, meaning you have 20%, okay? You having 20% of your right, okay, to ponteng. Okay, faham tak maksudnya? Maknanya, if you are thinking you're not for coming to the class, I'm okay with that. Okay, as long as you maintain that 30%. So you boleh kira lah kalau ada 10 minggu, okay, so you can chip out, okay, basically 2 minggu tak datang tak apa. Kalau you less than that, okay, even though, okay, you having a reason, okay, but you consider you are not attending. Okay. Jadi ayah ni cuba ni, kalau katakan dalam masa sembang macam ni, ayah dia panggil nama 3 kali, tak ada, ayah dia akan kira, akan ada catatan lain, nanti ayah dia akan semak, maknanya tidak hadir. Minggu lepas, I think untuk subjek apa, saya ada 3 orang. Okay? Jadi kena take seriously anak dia. So online ni actually is not, just really putting on, your apparatus, okay, your gadget, and you are disappearing. Okay. So I repeat, ini kali ketiga saya nak panggil ni. Farah, are you there?
Yes, Ayanda, saya ada.
Baik ada ha. Satu lagi, don't worry, okay, ayah anda actually basically nak, I just want you to talk, okay, whether your opinion actually is, wrong ke right, okay, it's okay, tak ada masalah, okay, because of, basically, I want you to take this opportunity, okay, I mean, for you to use, this platform, okay, to express yourself. Again, we can always learn, from mistake, okay, don't worry. Okay, ya Farah, okay. So, atuk you balik kampung kat mana, Farah? Where's your kampung?
Kota Baru, Kelantan.
Oh, bestnya. So jam lah baru ni balik Kota Baru kat mana?
Dekat Pasir Tomboh, Kubang Kerian.
Oh, okay. Ke Bangkerian. Okay, alright. Pernah sampai, dia pernah sampai tu. Kelantan semua sampai. Okay, so kalau nenek tanya, what is spectroscopy, Farah? So, how you going to answer? Because spectroscopy, you tak boleh, you nak cerita dekat nenek ni bukan orang teknikal. Kan? Dia orang layman. You tak boleh kata the study of molecular structure and dynamic through the absorption, tak jadi kan. Okay, how you going to explain to your apa ni? To your grandparents? Yang lain kena ready. Yang tanya soalan yang sama juga ni. Okay, sila Farah. Farah?
Ya, Ayanda.
Macam mana?
Okay. Saya bayangkan ayahanda ni atuk saya. Jadi saya akan saya akan ceritakan macam ni. Tok, kalaulah kita nak tahu sesuatu bahan tu, contoh structure, bentuk dia macam mana sebenarnya, bahan kita nak tahu lebih detail pasal bahan tu. Atuk pernah dengar tak pasal wavelength? Kalau dekat sekolah dulu pernah dengar kan? Jadi
Atuk pernah dengar wavelength tu apa?
Jadi Atuk, kita akan guna spektroskopi, kita akan belajar pasal structure, pasal atom dengan molekul bahan tu. So melalui wavelength yang apa tu, light radiation, daripada situlah kita tahu more pasal benda tu. Atuk faham ke?
Tak, Atuk tak faham.
Atuk tak faham? Alah Atuk, kalau macam tu saya panggil
Atuk tak faham benda wavelength. Tak apa, it's good Farah, it's good. Okay, it's good. Maknanya, okay, but the gist tadi actually for us, to know the structure, of certain chemical lah, certain chemical. Okay, so spectroscopy is one of them. So Atuk ni mungkin tak faham lah, okay, sebab wavelength ni apa kan sebenarnya ni. So,
Atuk. Ayahanda, maaf. Kalau macam tu saya nak panggil kawan saya untuk terangkan, boleh ke?
Kawan ni siapa?
Saya nak panggil Zahin. Saya rasa Zahin boleh terangkan dengan lebih lanjut untuk ayahanda faham.
Okey, tak apa. Boleh je. Okey. Siapa kawan you Rahim ni?
Zahin.
Dia dalam kelas ni ke?
Ya, betul.
Okey. Rahim?
Zahin Zafran.
Saya yang
Oh, Zahin. Okey, Zahin. Okey. Cuba buka video ni Zahin dengan Farah. Takut. Okey, Zahin. Okey, Farah. Okey, go ahead. Zahin is there. Okey.
Kena buka kamera ni. Tadi Ayanda kata apa?
Tak, ingat tu cukup buka video, ingatkan you nak apa ni? You dengan Farah nak berdialog, so elok buka video. Tapi kalau tak ada tak apalah, takut signal tak cantik. Okey. Okey, mulakan. Okey.
Saya try ada Ayanda.
Okey.
Kalau ada orang tanya kalau balik kampung kan, apa itu spektrum kan? Satu. First saya kata, okey contohlah. Duit raya warna hijau. Duit raya hijau warna RM5. Contoh. Metal yang warna hijau tu sebenarnya dia tak berwarna. Dia akan serap cahaya daripada matahari. Dan dia akan emit warna hijau tu. So, untuk cakap kat dia yang pasal, saya takkan cakap pasal apa ni kata complementary color tu. Saya just kata benda tu akan absorb cahaya dan emit warna hijau tu. Itu saya akan cakap lah benda pasal spektrum.
Okay, that's good. Maknanya you ada analogi duit raya tadi tu, duit RM5.
So setiap metal yang kat dunia ni, warna dia pada asalnya tak ada warna, tapi disebabkan cahaya tu dia mengeluarkan warna.
Okay, correct.
So last nanti spektrum ni just kita nak kaji benda tu, macam mana berlakunya benda tu. Daripada kalau dari segi eksperimen mungkin dia orang tak faham lah.
Right.
Tapi dari segi ambil kita yang belajar ni just kita kaitkan dengan apa orang panggil absorb, emit, itulah kita nak kaji benda tu.
Okey, pernah dengar tak ustaz saya kata bila kita nak berdakwah, kita kena hikmah, kan? Kena hikmah. Jadi kita kena, actually sometimes we need to be creative. So similarly, okay, when you explain, about spectroscopy, to layman, to atuk ke mak ayah ke sebagainya kan. Ayah dah letak example tadi. Sebab kadang-kadang kena buat macam tu, okay, supaya kita faham. Nak test whether we are really understand, okay, in certain concept, okay, try to explain it, okay, to your siblings, okay, try to explain it to your parents, okay, to your grandparents, okay. But if you're not confident, panggil kucing you, explain kat kucing tu. Cuma kat kucing dia tak argue kan. Kalau you dah agak kucing confident, okay, you explain kat orang lain. Okay. So contohnya macam kat kampung ni kan, I don't know, not kampung is very modern. Last time kampung ni macam ayah anda, kalau pergi ngaji malam-malam, ini we need to bring torchlight. Kan? Torchlight tu, bila you suluh tu kan, you akan nampak kan, oh ni pokok ni. Sebab apa? Sebab cahaya tu ada kan, cahaya tu ada. Kan? Jadi bila cahaya tu, macam kita guna tu visible light, okay? Visible light. Jadi cahaya tu mungkin tak dapat nak penetrate, okay, ke dalam objek yang kita suluh tu, okay. But then dia akan reflect balik, dan refleksi balik itu yang menyebabkan kita nampak kan, daun ke, okay, kereta ke, apa-apalah orang ke kan, hantu ke, kawan tak bahaya. Okay, itu adalah konsep spektroskopi sebenarnya nak dia. Okay, I mean the apa ni, you show the light, which is light ni adalah energy. Okay, EMR, electromagnetic radiation. So that light, bila you bagi light tu pada matter, dia akan ada interaction. Okay, matter ni maknanya any object lah. Dia akan ada interaction. Interaction tu could be, dia akan reflect balik. Dia akan reflect balik, maknanya dia sampai dekat macam cermin lah. Kita kena kat cermin tu, dia akan reflect balik. Dia akan serap, okay, dia akan serap, okay, dan dia akan serap, maknanya bila serap tu tak ada apa-apa, dia akan serap, okay. Dan ada juga dia serap, lepas tu dia keluar balik, kan. Dia serap dan dia keluar balik. Itu fluorescence. Okay. Kalau kita belajar ni, for the UV visible ni, actually cahaya UV atau cahaya UV atau cahaya visible itu, dia akan diserap. And that's it lah, dia akan diserap. So dalam tu macam-macam lah berlaku kan. Nanti kita akan excitation, that kind of thing. Tapi dalam fluorescent dia akan diserap juga cahaya tu. Lepas tu cahaya tu akan dikeluarkan balik. Okay? Dia akan ada emission. Okay? Ada emit. Kan? Contohnya macam kalau anak ni bawa kereta malam-malam kan, bawa kereta Myvi contoh. Jadi bila kena kat signage tu kan, lampu daripada Myvi tu akan kena kat signage, jadi boleh baca lah, oh bacok ataupun Kota Baru lagi beberapa kilometer. Tapi once lampu tu dah hilang, okay, once lampu tu dah gone, actually you tak boleh baca lagi dah, okay? You tak nampak sangat clear, okay? Itu adalah fluorescence, okay? Fluorescence. Dan kalau dalam itu, okay, macam dalam UV, okay, kita gunakan tenaga yang agak tinggi, okay, tenaga tinggi. Bila agak tinggi tu dia boleh menyebabkan atom tu dia akan menyerap dan dia akan become excited. Okay. Tapi kalau macam dengan IR, okay, macam it's like the one, okay, that you learn, with Prof. Chip 1. Infrared, okay, actually the amount of the energy is very weak, okay, it's very little. Bila dia tenaga dia sikit, dia tak boleh nak buat apa sangat. Okay? Mungkin dia tak boleh nak excite. Dia tak boleh nak excite elektron tu, tak cukup kuat tenaga tak nak untuk nak excite elektron. Jadi bila dia serap tu, dia cuma boleh menyebabkan molekul itu bergoyang-goyang. Dia akan twisting, dia akan bending macam tu. Kan? Dan luckily Allah susun molekul ini, sifat dia Masya Allah. Ini adalah sunatullah. Actually what we learning in spectroscopy actually is sunatullah. Okay? Kita belajar benda-benda yang Allah dah jadikan molekul-molekul ni. So kalau dia kena apa ni, electromagnetic radiation. Ayah kata EMR ataupun electromagnetic radiation because dia umum. Okay, very general. EMR can be microwave radiation. EMR can be infrared radiation. NR can be gamma ray. NR can be X-ray. Can be visible. Can be any light lah. Okay. Tapi kalau supposedly actually we supply the infrared rays, okay, atau infrared radiation. Dia punya amount actually is very little. So it's not enough. Basically the energy is not enough, okay, to excite the molecule. Tapi actually it's enough, okay, to cause the molecule to vibrate. Dia vibrate lah. Kalau macam ni kan, macam ni katakan pen ni dia stay. Bila kena tenaga tu dia akan dia vibrate macam tu. Mungkin macam ni ke, mungkin macam ni ke. And that vibration, subhanallah, that vibration tu memberikan maklumat mengenai molekul tu. Sebab setiap molekul tu dia punya vibration tu berbeza-beza. Macam tu. Okay. Jadi alhamdulillah bila dikena dengan cahaya tu, dikena dengan infrared tu akan menyebabkan dia mungkin bending, mungkin dia twisting, dan banyak lagi lah yang kita belajar tu. Dan itu berkaitan dengan jenis bond yang dia ada. Kan? Contohnya kalau dia ada double bond, ataupun mungkin hidrogen tu terikat dengan karbon yang double bond dengan karbon lain. Dia punya cara getaran dia berbeza. I mean the vibration is different compared to kalau hidrogen tu di attach to carbon, dan carbon tu mungkin triple bond dengan karbon yang lain, ataupun di single bond karbon yang berbeza. And then supposedly dia carbon tu dia bond dengan satu lagi carbon, and then mungkin dekat carbon yang sama tu ada pula halogen. Dia berbeza. Kan? Jadi sebab itulah dia akan memberikan satu phenomenon yang slightly berbeza. That's why kita lihat signal tu adalah berbeza. Jadi basically from the spectrum, especially in the fingerprint region. What they call it fingerprint? Sebab like our thumb kan, dia fingerprint, our thumb ni kan fingerprint. Okay. Jadi molecule pun molecule also having their own fingerprint. And therefore fingerprint we should be able to identify what sort of molecule that presence, what sort of functional group available in our molecule, for instance. Okay. So gunakan bahasa-bahasa yang simple dengan dengan your parents ke untuk mudah dipaham. Okay. Guna cap jari pun tak apa dah. Kan? Cuma bila spektroskopi ni kita kata kita belajar untuk nak detect cap jari untuk molekul. Macam tu kan, untuk molekul. Molekul tak nampak, tapi dia ada. Alright. Okay, that's good. Jadi ayah dia teruskan. Teruskan. Alright, jadi I mean in the proper words, spectroscopy is study of molecular structure and dynamics through the absorption, emission, and scattering of light and light EML2, electromagnetic radiation. So the general term that we use. So spectroscopy is study of the molecular structure and the dynamic. Maknanya maybe the vibration, the rotation that they have. So we study it together. Through the absorption of light, like in the UV spectroscopy, through the emission of light, like what we observe in the fluorescence, and like scattering of light as well. We can scatter the light. I mean, the scattering that happen in the light can also give some information about the molecule as well. Right. Let's start plan. Okay. And what is light? Actually, I don't want to repeat this if possible. You learned about this already, during your secondary school. So according to Maxwell, light is an electromagnetic field. And I think you know this what you call it, this expression, magnetic expression. Where the frequency is equal to the what you call it, the velocity over lambda. And if you took, the electromagnetic spectrum, in a I mean, as a holistic approach, I think you will see, there are many types of what you call it, electromagnetic radiation. Among others, you can see from here, we're having, the radio wave. We're having the microwave. We're having, the visible. That's radio wave ni. Microwave, infrared, visible, ultraviolets, X-ray. We have a soft X-ray, and we have hard X-ray, gamma ray, and so on. And actually, you can really they also put you the source of wavelength. Meaning, if you're talking about radio wave, so the size of the wavelength, is about a size of a house or a size of a soccer. Meaning the punya wave tu is very big. And therefore, we expect the energy actually is not very strong. The energy is not very strong. And then like for the infrared, infrared. So actually, it's enough. I mean to vibrate near the cell. Okay, and we have cells of bacteria and so on. Okay, so basically, you know, all these things here, okay, dimension size of wavelength, okay, they're putting, you know, something okay like, you know, soccer field, house, okay, baseball, just to relate, just to give, just to give us, you know, I mean the idea, okay, regarding, you know, the size of the wavelength. Okay, so of course we expect the smaller the size of the wavelength is, you know, the stronger, you know, the energy that's going to be provided, okay, by the AMR. And you can see the wavelength here, okay, getting shorter and shorter. And here actually the frequency, and here actually is the energy. Okay, so you moving, you know, from the left to right, the energy is increasing, isn't it? Okay, so that's why, for instance, in X-ray, okay, X-ray actually, you know, when you do your medical checkup, okay, when you want to enter USIM, okay, last time, okay, you asked to make a medical checkup and to undergo, you know, this X-ray. This one, for the X-ray, you are only allowed to do your X-ray twice a year. Okay, every 6 months you allow, okay, minimum up to 6 months. Okay, because of the energy, okay, from the X-ray actually is able, okay, to damage our cell, okay, in our body. That's why they put a limit. Right. All of it, another banyak-banyak ni kan yang EMR ini. Kita cuma belajar ni saja. Okay, actually we going to focus on this very small portion of visible and UV light. Okay, and the rest tu actually kita tak kaji lah, ataupun mungkin some of them you already discuss, you know, with Cik Wan, you know, on the infrared. Okay, infrared. Okay, so meaning, okay, meaning actually, you know, ilmu Allah SWT ni actually sangat luas lah. Okay, what we do actually just very small portion of it. Okay. So this is the idea, you know, to give, you know, the radio wave, which is very big, IR here, and then, you know, the X-ray, you know, so dia punya apa, frekuensi sangat rapat. And if you redraw, actually this just, you know, yeah, this is actually another way of presenting, you know, the EMR spectrum. So you can see from here, okay, you know, the ranging of the EMR. Okay, we have, you know, the gamma ray, X-ray, and we're having, you know, the what we call it, ultrasonic, NMR radio, and so on. So just to highlight actually what we're going to focus actually on the UV and visible. Why they call it visible? Any idea? Another, why we call it UV and visible light? Any idea why we call it visible? Why we call it visible light? Any idea, Ananda, why we call it visible light? Siapa? Bagi Faris lah, Muhammad Faris. Are you there, Faris? Ada kalau boleh tak nak panggil nama orang ni semuanya ni. Okay. Tapi tak volunteer kena panggil juga. Faris, are you there?
Yes, sir.
Okay, Faris. Why they call it visible light? Kenapa dipanggil visible light?
Because itu light yang kita boleh nampak dengan mata kasar.
Mata kasar. Berapa jarak dia light yang kita boleh nampak ni? Any idea what's the range light?
Sekejap saya masih ingat tapi saya nak cari balik sekejap.
Tak apa, belasah je.
Pasal
Whatever yang you ingat.
dalam 380 nanometer macam tu.
Sampai
700-800 nanometer. Kalau itu kan eksperimen kita buat hari tu lah.
Okay, that's good. Okay, so a big clap to Paris. Okay. So the first answer just now, okay, because we call it invisible because actually that light, I mean we can see that light. Okay. So sekarang ni anda nampak warna hijau hari raya baru ni kan, warna-warni di hari raya kan, warna hijau, biru, purple, okay, kuning, okay, semua adalah warna-warna yang kita boleh nampak visible. Meaning our light actually is very limited. Okay. You compare the MR just now kan, very wide, okay, but actually Allah limit saja yang kita nampak ni visible saja, kan, visible saja. Meaning, okay, we can only observe macam yang Faris sebut tadi, okay, we can observe more or less like from 350 nanometer to around about say 750, so in that range saja. Okay, sebab itulah tak boleh nampak tak boleh nampak setan, tak boleh nampak orang bunian, okay, tak boleh nampak, okay, hantu, okay, because of kita cuma boleh nampak dalam visible saja, visible light. Jadi rasa-rasa for those, okay, I mean for the object that we can't see, okay, for the object that we can't see, you think can we make it, okay, to see it? Faham tak soalan anda? Okay, for the object that we can't see at the moment, okay, for the object that you can't see at the moment, do you think in the future with the advancement, of the science technology, do you think we can able to see it? Agak-agak boleh tak? One day, okay, kita mungkin boleh nampak, boleh tak nampak ni kita boleh bagi dia nampak dengan teknologi. Agak boleh tak Zahin? Zahin ni saya jumpa dia itu masa Amali kan. Zahin, okey. Agak boleh tak in the near future kita boleh nampak benda kita tak nampak?
Kalau dari segi mata kita saja mungkin possible kot. Tapi kalau alat boleh kot.
Kuat sikit Zahin.
Tak dengar apa tu?
Kuat sikit.
Dengar ada. Prof.
Okey. So macam mana agak bagi nampak?
Mata kita kan dah diciptakan. Saya rasa tak boleh kot.
Okay.
Tapi kalau menggunakan alat ke ataupun cermata ke mungkin boleh kot. Tapi macam bahaya je Prof.
Okay, you kata boleh tapi dengan cermata. Alright. Ada sure boleh insyaAllah. Sebab sekarang ni pun, dalam keadaan sekarang ni pun, dalam keadaan mata kita ni, we can only see through 350 to 750. Okay. Tapi ada setengah orang yang Allah bagi untuk nampak benda-benda yang tak sepatut nampak. Orang lain tak nampak, dia nampak. Okay. Maknanya, ada setengah orang yang Allah bagi, dia boleh nampak beyond, okay, beyond nampak. Dia boleh, they can see beyond the visible region. They can see. Maknanya, with this pair of eyes yang kita ada ni, okay, sebenarnya possible, okay, untuk kita melihat, okay, yang kita tak nampak. Okay. Dan segi scientifically is proven, okay, boleh, okay, boleh. Contohnya, okay, dalam research, okay, ini we talk about the visible kan. Satu lagi adalah fluorescent, okay, fluorescent because they fluoresce, okay, they fluoresce. Fluorescent ni dia fluoresce, dan the fluorescent tu because it's not many molecules can fluoresce, so that's giving something special, okay, to fluorescent techniques. Okay. Jadi apa yang dia orang buat, okay, bila dia tengok, okay, for instance, okay, when they see the analyte actually is not fluorescing, kan, dia nak kaji analyte itu, tapi dia nak guna keadaan fluorescence, tapi analyte itu dia tak fluoresce. Dia nak guna fluorescence kerana fluorescence itu adalah metode yang sensitif dan very selective. Okay. Sebab kalau guna UV, banyak molekul yang boleh serap UV, jadi dia akan menjadi tidak selektif dan tidak sensitif juga. Tidak selektif lah partikel tidak selektif, because banyak sangat. Tapi kalau fluorescent, very few, okay, molecule who can fluoresce. So if you can make the molecule fluoresce, okay, very good. So what they did, okay, ini dari start dah ramai orang buat dah. Okay, ayah ni bila key in tu dah beribu papers, okay, been published. Jadi dia tag molekul itu dengan satu bahan yang fluoresce. Okay. Contohnya fluoresin, dari fluoresin tu dan dia tag, diikat. Chemistry boleh buat kan? Chemistry kita boleh ikat molekul. Jadi apa dia buat? Okay, dia ambil fluoresin itu dan diikat fluoresin itu kepada molekul tidak fluoresce itu. Hasilnya kita boleh observe. Jadi bila masuk dekat, okay, we can detect by using UV fluorescence spectroscopy. So we can see, we can quantify the concentration and so on. So similarly, it's the same thing. Okay, I mean, you're talking about, macam benda-benda tak nampak ni kan. If you are able, to tag them, if you're able to tag them with something visible, okay, something is visible, okay, we should be able to see them. Okay, so think about it. Okay, so maybe in the near future, okay, you will be able, okay, to see benda-benda yang tak nampak. Okay, right. So EMR, okay, EMR ini more or less, the spectrum of it. Okay, you can see, all these beautiful colors. Okay, as what been explained by Zahin just now, okay. I mean the color that we see, okay, the blue color, contohnya blue color, you nampak blue color ni, because actually hanya blue color yang tidak diabsorb, okay. Yang the rest tu diabsorb, okay. So basically what you see actually basically the complement, okay, of the colors that have been absorbed. Okay, I don't want to explain that further because you already learned about this previously. But you can see from here basically, you know, we're talking about the visible light, okay. So it's ranging. Actually visible light yang ni. Okay, jadi visible light ni memang kita boleh nampak lah all this color. Okay, we can see the contrast, you know, red, yellow, green, blue, you know, purples. You know. But you know, I mean, before the visible light, actually we're having before that, even before that, actually we're having, you know, the UV. Okay, UV ni pun we can see. Okay, tapi UV ni kita boleh rasa. Okay, supposedly if you you know, if you walk along, you know, the bush, you know, it's very hot temperature, okay, for instance, okay, very sunny day, okay, you can feel, okay, I mean the UV actually hitting, you know, your skin, okay, dia rasa perit sangat-sangat, okay, that actually is caused by UV, okay, and cause, you know, your skin become very dry, okay, that's why you need to use you know, the UV protector. Basically UV protector, instead of using your skin, okay, I mean, instead of absorbing into your skin, the UV will be absorbed by, okay, by the skin protector, okay. And beyond that, actually, we are going to infrared, okay. But now it's like, you know, the instrument that we have, okay, in the lab, okay. When you enter the lab, okay, actually we have this instrument, okay, but at the moment the instrument is not working. The one that you use actually, the one that you use in your experiment actually is called, you know, it's a called single beam instrument, okay? But we also having, you know, the double beam instrument. We're going to discuss about that later, yeah. Okay, another, this is what I'm saying, you know, actually we're having, you know, a spectroscopic technique. We have so many spectroscopic technique, okay. It's like visible, the one that we are discussing now, okay. Atomic absorptions, okay. I don't know, if this is part of this, but I think atomic absorption has been discussed in analytical chemistry, if I'm not mistaken. FTIR, okay, so in this subject, okay, we learned about FTIR as well. I think you already learned about this, okay, with Chip 1. And then we're having Raman, okay, FTNMR, like what we're going to discuss, and X-ray spectroscopy, crystallography. So you can see here basically, you know, the MR region, okay, that responsible, okay, that is going to be used, you know, for this, what you call it, okay, for this spectroscopic techniques. And basically, here are the information, okay, or the mechanism, okay, that's going to occur. Okay, for instance, in FTIR, okay, actually, what really happened, you know, when you supply, okay, when you supply, you know, the infrared or microwave energy, okay, to the molecule start to vibrate and also rotate. Okay, so I mean, from this vibration and rotation, okay, we are able, you know, to determine lah, okay, what sort of, you know, functional group available, okay, in the what you call it, in the molecule. And if you are using X-ray spectroscopy, actually we are going to use X-ray, you know, as the source of energy that will be supplied, okay, to the our analyte. And in this case, actually, you know, the signal has been generated, okay, through the what I call it, I mean the transition, okay, which is going to involve, you know, the inner electrons, okay. In UV visible, okay, we are dealing with bonding electron, okay, which is the outer electrons, okay. But in X-ray spectroscopy, we are dealing with the inner electron, meaning, okay, the inner electron, actually the electron that's, you know, I mean, circulating the nucleus, okay, very closely, okay. So the electrons that are close, you know, to the nucleus, okay, meaning the binding actually very strong. The attraction, okay, to the nucleus is very strong, and we need higher energy in order to move them. That's why we use X-ray. But with UV visible, actually the energy that we supply is not strong enough, okay, to move the inner electron. As a result, they're going to move only the outer electron. Okay, so these are kind of, you know, the NMR, you know, macam apa ni, they just merely, I mean, the activity, okay, that's going to be, I mean, it's going to happen, you know, within the molecule. Okay? Macam microwave ni, okay, just merely rotation, okay, the energy is, you know, only for rotation. Infrared, okay, basically, okay, for I mean, to do vibration, okay, and so on and so forth. Macam visible ni, okay, dia cuma, okay, outer electron is going to involve, X-ray is going to involve, you know, the inner electron and so on. Okay, I'm going to stop here for a while. Okay, I'm going to show videos, you know, maybe the videos is focusing on the interaction, okay, between light, okay, and molecule. The videos is around about 7 minutes. I want you to pay attention, okay, on it. Okay, and then we're going to discuss a bit about it. Okay, Ananda. So I stop this for a while. Okay, so light and matter. Dengar tak audio dia, Ananda?
Dengar.
Okay, good. So pay attention.
Hi, it's Mr. Anderson, and this is Chemistry Essentials video 10. It's on light and matter. Matter is what we're made of, but I've got some matter on the screen and you can't see it because there's no light. Once I add light, we start to see matter. And so we can see solid, liquid, gas, and plasma. And so until we have light, we really can't probe matter and figure out what it's made up of. And so in this video, I'm going to talk about light and matter. Remember, light travels in these little packets called photons, and we can quantify its light using Planck's equation, where energy is equal to h nu, and h is going to be Planck's constant, nu is going to be the frequency of the light. But we can use these little photons to probe matter and figure out what it is. Because if you have a molecule and it absorbs a photon, it absorbs a certain amount of that energy. And when it releases a photon, it releases some of that energy as well. And so we can use different types of photons to figure out different things about molecules. And so infrared light is incredibly important at looking at the vibrations within atoms and molecules and figuring out what bonds they have. If we're using ultraviolet or visible light, we can look at the electronic structure. In other words, where the electrons are found, the outer electrons, and what they're doing. And then finally, we can look at solutions using light. And as we shine light through a solution, some of that light is going to be absorbed. And so we can figure out, according to Beer-Lambert law, what is the concentration of those absorbing molecules. And so light, remember, is a wave and a particle. And so if we're looking at it as a wave, we have what's called the electromagnetic spectrum, all the way from radio waves to gamma rays. Radio waves are going to have a really long wavelength and a low frequency. That's how many waves we have per second. Gamma rays are going to have really high frequency, small wavelength. And we're just seeing a small portion of that. When you look at me, you're only seeing visible light. And so light is a wave. Light is also, however, a particle. And what that means is it's quantized, or it comes in these small little quantities. And so you could think of it like this. And let me play some music in the background. This is Rachmaninoff for violin and piano. Vocalize. And so a violin can play any note. You just move your finger up just in incremental amounts, and you can get any note. But a piano is going to be quantized. You're going to have specific quantities. You can only hit a C or a D or an E. And so really, which is light? Light is like a piano. It comes in these small little quantities of photons. And so we can measure that energy using Planck's equation, where h times nu is going to be Planck's constant times the frequency of the light. And so which of these wavelengths are going to have the highest amount of energy? Ones with the highest frequency, and those are going to be the gamma rays right up here. Which ones are going to have really low energy? Those are going to be the radio waves down at the bottom. And so what we can do is we can measure photons and how they're picked up by atoms, and it tells us a lot about what the electrons are doing. And so a spectroscope allows us to see this whole electromagnetic spectrum. One of the first scientists to do this was Newton. If you wanted to build one of your own, all you would need is a prism and then a small slit. So we run light through it, and it's going to split that light into the different colors that we could see. And so this would be a compact fluorescent, and you can see the different light colors of light that are coming from it. In a typical chemistry class, you'll just use a cheap spectroscope like this. It's going to have a slit on one side, and then it's going to have diffraction grating on the other side, and then an eyepiece down here. And so when you look at a light, it's going to look like this. But if we were to look at an incandescent light, it's going to look different. We can look at different atoms, and it tells us a lot about their electrons. And so a spectrometer is simply a sophisticated spectroscope. What you're going to have is a source. So we're going to have some light on one side. We're then going to have a grating, and the detector now is going to be a camera. It's just like a digital camera that's picking up more of the light that we can't see. And what you do is you take your sample and then you slide it in like that. And so different spectrometers are going to allow us to see different things. And so in IR spectroscopy, what we're looking at is infrared light. And so what's interesting about atoms is that they're vibrating constantly. There's going to be a vibration between atoms and between molecules as well. And so let me give you some example. This would be a carbon and two hydrogens. And what they have are called degrees of freedom. And so there's going to be a lot of vibration going on within a molecule. And what you can have happen is that when you introduce infrared light, it can actually pick up some of that energy. The bond's going to pick up some of the energy of that infrared light, and it's going to make these vibrate even more. It's kind of like pushing somebody on a swing. If you keep pushing them at the right rate, eventually they go higher and higher and higher. And so what happens to that infrared light? It's absorbed. And so what we can do is we can use an IR spectroscope, and we can look at what frequencies of light are being absorbed, and then we can use a fingerprint or a correlation like this, and it's going to tell us what kind of bonds we're going to find within that molecule. Now, if we wanted to look at more of the electronic structure, then we'd be using UV or visible light. And so what we're doing here is same kind of a thing, spectroscope, where we have light, we have a detector, and this time we're just using UV light or visible light. And what we'll find is instead of vibrating those molecules, what we're figuring out is that the photons are being absorbed by electrons. They're moving up to a higher energy level. And so that's where the energy is going. And so we can use a spectrum like this, and it's going to tell us more what those valence electrons or the electrons on the outside are doing. And then we finally have Beer-Lambert law. And what that is, here's an example right here. We have a dye, and then we're shining a green laser into it. And what we're finding is that laser light isn't making it all the way through. And that's because we have molecules on the inside that are absorbing some of that light. And so here's an application of that. It's just a simulation from PHET. We have a light on this side, and then what we're going to do is we're going to measure the amount of light that's moving through it. So I've turned the light on, and we're going to set that to absorbance. It's the amount of light that gets through, and we're dealing with cobalt chloride. And so what we've got is a solution. You can see as I turn down the concentration, more light goes through, and as I increase the concentration, less light is making its way through. And so this is Beer-Lambert law. Basically, as I increase the concentration, less light makes its way through. And so I can do a quick little experiment here. I could set it at 0, and now at 50, and now at 100. Look what happens as we increase it to now 150. Look what's happening to the absorbance. More of it is being absorbed. Now let's move it to 250. And so here's my data right here, where on the left I have the concentration, on the right I have the absorbance. And you can see it looks like a pretty linear relationship. Let's graph it. So that's perfect. And so what we're finding is as we increase the concentration of the solution, more of that light is being absorbed. And so what you could now use is you could just take a sample, we could measure the absorbance of it, and then we could figure out specifically what is the concentration of that solution. And so what did we learn? That light, and using Planck's equation, is travels in these little photons, and we could quantify that. We can use it to probe matter, and that's because molecules are picking up or letting go of these photons. And then remember the three major things. Infrared light allows us to look at the vibrations of molecules and tells us a lot about what their bonds are. Ultraviolet and visible light tell us more about their electronic structure, where the electrons are. And then in solutions, those absorbing materials, remember, will pick up some of that light, and so we can use Beer-Lambert's law to make predictions on the concentration based on the absorbance level. So you should have learned to choose the correct spectroscopy to measure vibrational or electronic motion of molecules. So again, if you're looking at vibrational, you better choose infrared, and if we're looking at electronic structure, then you should choose UV or visible light. And then finally, we could use the absorption of light to determine the concentration of absorbing species in a solution. That's Beer-Lambert law. As we increase the concentration, we increase absorbance, and I hope that was helpful.
Okay, another, what can you learn from this? Okay. From that 7-8 minutes of videos, what you can learn, what you can say about the spectroscopy. Actually, from the, he did mention about the piano and also violin, okay, and try to relate that, with the quantized energy and continuum energy. Any idea about that? Any idea about that? Okay, ada tanya Najihah lah. Okay, Nurul Najihah. Nurul Najihah, are you still there? Nurul Najihah, are you there? Nurul Najihah? Okay, last call. Last call. Nurul Najihah, are you there?
Yes, sir.
Baik ada. Okay, Nurul. Okay, tell me about the violin and also the piano. Najihah. Where are you now?
Pasal wavelength, Doktor.
Where are you now, Najihah?
Dekat rumah sewa.
Sewa dekat Anggrek ke? Where's your rumah sewa?
Desa Jati.
Desa Jati. Ini ramai kawan-kawan belakang tu kawan-kawan ke tu?
Housemate.
You tanya dia. Susah tanya dia. Okay, just kidding. Alright, okay. So tell me about the violin and also the piano. Okay. How can we relate that with energy? Pernah tengok violin tak, Najihah?
Pernah, Doktor.
Macam dia main violin, macam mana dia main? Tak, macam mana dia main violin? Pakai gesek ke, pakai gendang ke, pakai...
Dia ada tali, Doktor.
Okay, dia bertali dan dia ada penggesek dia lah kan? Pakai piano?
Piano dia pakai macam tiles
Okay.
yang banyak-banyak tu.
So, kalau macam piano ni, dia sekali picit, dia akan keluar bunyi kan? Picit satu, keluar satu. Macam keyboard lah kan? Picit satu, keluar satu. Picit satu, keluar bunyi. Tapi kalau violin, dia tak baik picit-picit kan? Dia gesek, dia continuously. Betul?
Ya, Doktor.
Okay. So, how can you relate that? Because they're talking about the quantized energy. Okay, quantized energy. So, kalau nak relatekan quantized energy ni, yang mana? Yang piano ke, yang violin? Najihah?
Violin.
Violin? Violin tu yang quantized. Tak faham you ni. Okay, quantized ni actually dia discrete tau, dia discrete. Okay, discrete maknanya, okay, dia ikut batch lah. Satu batch, okay. Keluar satu. Macam violin lah. Sorry, macam piano. You tekan, keluar satu bunyi. Tekan satu bunyi. Tapi kalau macam violin, okay, you gesek tu, bunyi itu adalah secara berterusan. Okay, berterusan. Jadi, quantized energy itu adalah seperti piano tadi. Alright. Okay, what else can you ni? Okay, anak dia yang lain macam mana? Ayah dia nak berhenti dah ni. Okay, dia dah 1.5 tak mau you kacau lama-lama. Okay, tapi nak kena jawab soalan dulu ni. What can you get, from the videos? Okay? Otherwise, actually, maybe I just wasting my time, okay, sharing the videos and you not learn anything from there. Nak tanya anak dia Anis Afifah. Anis, are you there? Okay, kali kedua, Anis. Ni Anis Afifah. Binti ni Asif. Are you there?
Ya, saya, Doktor.
Baik, ada. Halus je suara dia. Where are you now, ni Anis?
Kat rumah sewa.
Sewa di mana? Di Sejati juga? Tak ramai menyewa. So most of you prefer to rent house rather than staying in student accommodation. So how about the internet? Okay, I mean you have no problem, with the internet at your rented house. Ni Anis ada masalah.
Kadang-kadang okey, kadang-kadang tak.
Oh, kadang-kadang okey, kadang-kadang tak. Kenapa tak datang ke office, datang ke USIM? Kalau masa kuliah ni datanglah USIM. Duduk dekat library ke? Duduk kat rumah. So anyway, okay, Nak Anis, what can you learn? What the thing that you can share, with the rest of the group, based on the videos that you just watched? Anything? Banyak ni tadi video tu, 7 minit tu.
Kalau nak tahu light tu kena tahu dia punya concentration sebab daripada keluar tadi.
Kalau nak tahu apa light, kena tahu concentration.
Ni kalau nak tahu light absorbent, kena tahu concentration dia sebab daripada law tu increase the light absorbent tu increase the concentration akan increase absorbent light.
Apa nama law tu, anak dia? What's the law called?
Beer-Lambert law.
Okay, Beer-Lambert law. Okay, what's Beer-Lambert law says? Beer-Lambert law ni cerita pasal apa? Relationship between tadi kan di plot graph yang lurus tu, maknanya dia relationship between, you sebut tadi dah, concentration and ni Anis, you mentioned just now. Alright, jadi dia adalah concentration, okay, versus absorbance, alright. Okay, itu satu yang we can see from that, okay. I mean they use their simulation kan, okay. Once they move, okay, the absorbance, okay. So you will see, once they move the concentration, okay, they increase the concentration, the absorbance will also increase, okay. So more or less it's like directly proportional, okay. So that's one thing lah, okay, that you can observe, from the video. Apart from that, is there anything else? Is there anything else? How about the energy? If we are having, okay, if we are providing, okay, the material, with low energy and with high energy. Okay, so what can the material do with the lower energy, and what can they do, with the high energy? Kan, dari sebut kan, kalau low energy apa dia? Okay, kalau high energy apa yang berlaku? Anybody want to share? Faik, Ahmad Faik bin Sayuti. Yang tadi Afiq kan? Okay, ini Faik. Ahmad Faik, are you there, Ahmad Faik?
Yes, sir.
Yeah, okay, Ahmad Faik. So answer me. Ahmad Faik, you also, at your rented house, is it? Ahmad Faik dekat rumah sewa juga?
Yes, sir.
Oh, gambar handsome. Okay. Ahmad Faik, Sayuti, alright. Okay, Ahmad Faik, answer me.
Question ayah anda tadi apa ni? Kalau energy, energy.
Okay, if you supply, a lower energy and high energy, what can molecule do, with it? What sort of interaction that they're going to have? Faik gambar kat mana ni, ada benda dia boleh share ni, nampak cantik ni. Is it somewhere, you know, at the peak of, you know, mountain or something? Tak apa, fine. Okay, teruskan.
Kalau low supply energy, apa tadi?
Tak. If you supply, you know, lower energy or higher energy, okay, to the molecules, what's going to happen? Dapat tak soalan tu? Okay, if we supply energy, if we supply lower energy to the molecule, and if we supply high energy, okay, so what's going to happen? What's the interaction that's going to occur? Ada tadi sebut dalam conclusion tadi.
The molecule will collide with each other.
Will call each other, collapse.
Collide, melanggar.
Collapse, collapse. Collapse.
I mean collision between molecule.
Collide, okay, collide each other.
Yeah.
Tak, dia ada cerita mana? Ada cerita tadi tu. Ini photon, okay, mana dia cerita collide? I know what you talking, okay. Ini kalau kita panaskan, okay, macam bahan, mungkin energi tu tak sampai that level, kan. Energi kita bagi tu tinggi tapi tak sampai that level yang dia boleh, okay, menyebabkan pergerakan molekul tu dah berlanggaran dan semua lain. So mostly because actually we're talking regarding the spectroscopy, okay, maknanya daripada you know, daripada IR tadi sampailah ke apa ni, ke UV visible. So basically at lower temperature, at lower energy, basically, you know, the molecule can only do rotation and also vibration the most lah. Okay, they can rotate. Rotation actually taking the least energy, and tenaga paling rendah tu kita it can cause, you know, the molecule to rotate. Okay. Sorry, I mean to rotate, okay, to rotate. High energy will cause them, okay, to vibrate, okay. And finally, when the energy reach, you know, the UV and visible region, it's going to cause, you know, the molecule, okay, to be excited, okay. I mean, the outer electron is going to be excited to higher level, okay. So lower energy will cause the molecule to do rotations, okay. The molecule is going to rotate, and you know, if we supply even high energy, so the energy will be enough again to cause the molecule to vibrate. Okay, so vibrate and rotate jangan confuse. Okay, so rotate ni dia just rotation macam ni kan. Dia rotate macam tu je. Okay. Jadi sini satu atom, so dia just rotate. Tapi kalau dia vibrate, okay, dia akan mungkin macam ni, okay, dia vibrate. Laju lah. Okay, laju macam tu. Kalau dia ada dua, okay, kalau dia dua, contoh macam air kan, molekul atom, jadi dia mungkin boleh macam tu, dia boleh scissoring, okay, and so on. So I mean based on understanding, okay, Faik, untuk rotation dan untuk vibration berlaku, okay, so which one actually need high energy, okay? Is it rotation need high energy or is it vibration need high energy? Faik.
Rotation with high energy.
Rotation high energy, okay? Right, maknanya inilah dia pusing macam tu je. Ini rotation, okay? Rotation, okay? So dia tak bergerak mana, dia cuma rotate, dia akan paksi dia saja macam tu. Tapi kalau untuk vibration, dia akan vibrate, okay? Dia akan banyak mode lah. Satu adalah mode scissoring dia panggil, dia panggil scissoring. Scissoring macam gunting lah kan, dia tutup, dia buka, tutup, buka. Ini hopefully Cik Wan dah cerita kat you lah. And then mungkin satu lagi macam ni. Ini satu ke depan, satu ke belakang, satu depan, satu belakang. Logiknya yang mana banyak gerakan? Rotation ke ataupun vibration? Faik. Yang mana banyak bergerakan? Is it rotation ataupun
vibration?
Vibration, okay. Jadi you faham daripada apa yang dia contoh tadi, okay. Sebab kalau rotation dia slow steady saja. kan macam tai chi tu slow aja, dia tak perlu banyak tenaga. Tapi kalau vibration, dia perlu banyak tenaga ni, dia agresif. Jadi untuk dia perlukan banyak tenaga, jadi dia perlu tenaga tinggi ke tenaga rendah? Fine. Fine. Jadi untuk dia rotate ataupun untuk dia vibrate, okay. So mana tenaga yang tinggi dia perlukan? Tenaga tinggi diperlukan untuk vibrate ke untuk rotate?
I think vibrate.
Vibrate. Okay, macam tu confident je. Hati-hati tak main confident kali. It must be vibration. Okay, because of dia banyak pergerakan, so they need more energy. Okay. Tapi kalau katakan dia nak menyebabkan, okay, satu atom, okay, satu elektron daripada atom tu dikeluarkan, okay, daripada atom berkenaan, itu even high energy is needed. Okay, betul tak? Dia nak keluarkan satu elektron, outer elektron, okay, to be expelled, okay, out, from the orbit, okay, daripada atom kan, untuk dikeluarkan, untuk to be excited, okay, that's even need high energy, okay. So kalau setakat supply energy, okay, untuk dalam infrared ni just cukup untuk vibration, okay. Tenaga dalam jumlah infrared, that's enough untuk vibration. That's why dalam IR, spectroscopy, kita bagi IR tu as energy, EMR, electromagnetic radiation, dan dia tenaga tu cukup untuk vibration tu berlaku. Okay. Macam NMR, we talking about spin. NMR kita bagi nuclear magnetic resonance, ya. Jadi energy itu adalah lagi rendah, okay, lagi rendah. Dia just cuma rotation saja kepada spin, okay, yang akan berlaku, okay, pada paksi yang sama, paksi tak bergerak. Okay, I think that's about all. Okay, so maybe it's a bit lengthy and it's a bit tedious to you. Okay, but I'm explaining that. Okay, hopefully you are able to see the videos again, and then maybe go through, my notes and try to add some more. It seems that some of you still having some difficulties, okay, in explaining the concept, of the spectroscopy. Jadi kalau nenek tanya, mungkin you tak boleh jawab dengan bagus lagi ni. Okay. So my expectation, you should be able, okay, to differentiate between UV visible spectroscopy, infrared spectroscopy, okay, dan mungkin NMR spectroscopy in terms of energy, because UV dengan fluorescent tu, the energy more or less is the same. We're talking about the same region of electromagnetic radiation. Okay, UV visible and fluorescent, okay, basically we are dealing with the same range of energy, okay, which is UV and visible. Okay. Tapi untuk nuclear magnetic resonance, okay, we even needs, very, very, very low energy. Okay. And infrared, okay, we supplying infrared, EMR in infrared region, and that infrared that we supply actually is enough, okay, to cause the molecule to vibrate. So regardless, okay, whether the speed of nucleus that going to change, whether the rotation again that going to occur, or whether the rotation that's going to occur, whether the vibration that's going to occur, or maybe the excitation that's going to occur, all of them, okay, is going to have their own characteristic, and each of them is going to contribute in giving us information about the molecules. Alright. Jadi kalau molekul tu dia boleh menyerap UV visible, okay, meaning, okay, that is containing some loose electron, okay, contain some loose electron. So we expect molecule that able to absorb UV visible light, okay, should have some loose electron in it, okay. So which is, we call it, unsaturated electron, which is maybe they containing some unsaturated bond, okay, macam double bond, triple bond, subconjugation. We expect that, okay, that kind of information that we're going to have. Okay, and then if you supply, the infrared, the rotation and the vibration that occur, the vibration is going to tell us something about the functional group that available, okay, in this molecule. All right. Okay. So, and the spin of the electron, any the rotation of the spin, of the molecule is going to give information, in this case, it can be focusing on the carbon and also hydrogen, okay? The number of hydrogen and the number of carbon, okay, that might available in our molecule. Okay, that is about all. I guess I'm going to end here. Okay, so I hope to see you again next week. Okay, so with that, okay, we end this session, okay, by reciting apa ni tasbih kifarah, okay, dan surah Al-Asr. Subhanallah wa bihamdihi, subhanallah wa bihamdika, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Don't forget your attendance, yeah. Your attendance actually is available, in online. Okay, so very soon it's going to be closed. Kalau dah tutup, ada komplain, oh yang anda lambat tak bagi, memang tak ada dah. Okay, dikira tidak hadir. Okay, so make sure that actually you can try to manage yourself. Okay, regarding your attendance. Attendance is very important, 80%. Okay, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.